Hello and welcome to Learning Chem 1201, where we'll learn partial charges and bond dipoles. Today we'll go over how to draw our Lewis structures, how to find partial charges and bond dipoles, how to find net molecular dipoles, and some common mistakes. So, how many molecules are polar? So, what does polar mean? Polar is going to mean that our domains are going to cancel in these molecules. So we're going to go through each one of these, draw out their Lewis structures and molecular geometry, and see which ones will be polar. So let's put that aside for now. The process is going to be very simple. We're going to draw out our Lewis structures, identify the bond dipoles using electronegativities, and identify the net molecular dipoles of each. All right, let's start off with SO3. So we know that S goes in the middle because it has the lowest electronegativity. And this could just be seen by using your periodic table and knowing that the electronegativity trend goes up towards helium, just like that. So it's very handy to keep this by your side while you're doing this. So sulfur will go in the middle with its lowest electronegativity charge. We do realize that oxygen has a higher electronegativity charge, so we're going to assign it the partial charges. This one being positive, and oxygen, of course, being negative because it has a greater electronegativity. So let's check our Lewis structure math. So sulfur has 6 electrons, oxygen has 6 electrons, and there are 3 oxygen atoms. So we're going to add those all together and receive 24 valence electrons. Alrighty, so first off the bat, we're going to realize that sulfur doesn't have a full octet, but we do realize that sulfur can violate octet rules when needed. Okay, and so let's count the domains and start assigning our molecular geometry. Okay, so sulfur will have 1, 2, 3 domains, right? And as we draw our dipoles, we're going to realize that our dipoles are going to travel from our positive and be attracted towards our negative. So it's going to drift from our lowest electronegativity to our highest electronegativity. So that is going to go from lowest sulfur right here and go to oxygen. So lowest sulfur and go to oxygen. And it's going to be the same for this one as well. So with those 3 domains, we can construct our molecular geometry. So S goes in the middle, O's on the outside. Okay, and what we come up with is that we realize that this molecular geometry presents a trigonal planar in which there are 3 bonds, 0 lone pairs. This means that each of these bonds are identical and that they will all be canceled. Okay, and with those canceled, we realize this will be a non-polar molecule. Okay, so we could scratch that off the list. Okay, set that aside. We're just going to OF2. O should be in the middle because it has the lowest electronegativity. And let's check our Lewis structure math. O has 6, fluorine has 7, 2 fluorine will equal 20 valence electrons. So our O gets assigned our lowest electronegativity and fluorine has our highest. Okay, our dipoles are going to go from our lowest electronegativity to our highest electronegativity. It'd be seen as here too. Okay, so let's first count the domains that oxygen forms. It has 1, 2, and then we're going to count our lone pairs, 3 and 4. So 4 domains, and this is going to present itself as a bent molecular geometry, in which there are 2 bonds, fluorine, and 2 lone pairs, which would be the leftover from our Lewis structure math. Okay, so we're going to realize that these do not cancel, and that is because these lone pairs are not going to cancel with fluorine because they're not the same bonds. That is going to result in a polar molecule. Alrighty, so BeCl2, we realize Be should go in the middle, has the lowest electronegativity, and chlorine on the outside. So let's check our Lewis structure math. All right, Be right here has 2, and chlorine has 7. 2 chlorine atoms equals 16 valency electrons for our structure. And Let's assign our partial charges. Has the lowest electronegativity, so it will have the positive, and chlorine will have the negative. So, since our positive will be attracted to our negative, our lowest electronegativity will be attracted to our highest, we will draw our dipoles from Be to chlorine. Okay, and after we do that, let's count the domains that Be makes, 1 and 2. Okay, so this molecule, for its molecular geometry, will present itself with 2 domains, which will form a linear molecular geometry, in which there are 2 bonds and 0 lone pairs. So we realize that chlorine, we're both going to cancel each other out because they make the exact same bond with Be. So this molecule will be nonpolar. So we can scratch that one off the list. CCl4, carbon should go in the middle because it has the lowest electronegativity. And our chlorines will go on the outside because they have the highest. So let's check our math. 4 electrons for carbon and 7 electrons for chlorine, and 4 chlorine atoms equal 32 valence electrons. Alrighty, so let's assign our charges. Positive in the middle, and all our chlorines will have negative. So since our lowest electronegativity will be attracted to our highest electronegativity of chlorine, all of our dipoles are going to go towards chlorine. Okay, so that gives us a good idea on how to draw our molecular structures. So we realize that carbon makes 4 domains, 1, 2, 3, 4 with chlorine. And this is going to form a tetrahedral molecular geometry in which there are 4 bonds and 0 lone pairs. So as you can imagine from now, all these chlorine atoms are going to cancel because they're making the exact same bond with each other in carbon. So this molecule will be, of course, nonpolar. And we can cancel out CCl off the list. Alrighty, and lastly we reach O3, or ozone. So this one's a little bit different. We realize that oxygen is going to have 6 electrons, and there are going to be 3 of them, equals 18. So let's be careful with this one. We have 2, 4, 6. It's going to be our 8th, because this is a resonance structure. And then we have 2, 4, 6, 8. That gives us 16, but we still have 2 left. So we're going to put those on the center atom, and these are all going to have the same charges, which we cannot draw our dipoles because none of these are going to have a relationship. So our oxygen has 3 domains, 1, 2, 3. It's going to form a bent molecular geometry of 2 bonds and 1 lone pair, as you can see on the top. And when we draw it out here, it's going to have oxygen in the middle, our 2 oxygen bonds, and our lone pair bond right here. And as we all know, if molecular geometry presents itself with a lone pair, we know that it's going to result in a polar molecule right here. Okay, so finally, some common mistakes, as in like SF2. Bond dipoles do not cancel simply because they are next to each other or they look like they're going to cancel. Don't let this deceive you. These are not all the same bonds. These 2 are and these 2 are, but that doesn't mean that they're going to cancel. As you can tell, with sulfur being in our lowest electronegativity and having the positive partial charge, and fluorine having our negative partial charge, our molecular geometries from sulfur are going to go towards fluorine in directions like these. That is not going to cancel out things in this molecular formula. Alrighty, so finally we can answer our questions. OF2 is going to be polar, and O3, ozone, will also be polar. Alrighty, and thanks for watching.